What is Sweepline? Sweepline is a simple but powerful algorithm that we can use to perform geometrical computations on a set of points or lines on the plane. So we use a very long line that can fit all the y values of every point in this or line in this plane, and we could just sweep it across like this. And for each point or line, we can stop at it and perform some type of operation or computation in order to help us find the answer. So how can this be used? An example problem is the closest pair problem, where you have many points in a plane like this, and you want to find the closest pair of 2 points. And an easy way to do this is just to get all the pairs of points on the plane and find the distance between each pair, and then we can find the smallest value. However, this is inefficient because it takes O of n squared time, because for each point you have to compare it to every other point. So by using Sweepline, we can reduce the time complexity to O of n log n, which is very good. So how do we do this? First of all, we want to sort the points by their x value, so we can go from left to right without missing any important points. And then we want to keep an active set, and this active set will keep track of the points by their y value. So we can first label these points 1, 2, 3, 4 for the sake of simplicity and to make it easier to explain. And we also have this d value. And what is d? D is just the current smallest distance between 2 points. And the first time we want to set this to the distance between the first 2 points sorted by their x value, and this will just be our current d. And we also want to push both of these 2 points because we have already performed our operation on them, and now we know that these are possible candidates to be part of the smallest pair. So we can move this line to the third point. And here we want to create a rectangle with height 2 times d and width 2 times d. So d is something like this. We want to create a rectangle like this. And you want to set this to d, and this is also d. And then we want to look through the set. And for every point, when we look through the set, we want to remove every value whose x value is less than whose x value is on the left of this box. So we can see that 2 fits within this box x value, but 1 does not. So we can remove 1 from the set because we know that this is not a possible candidate. And then we go through the set, which is only 2, but because 2's y value is less than, it does not fit, because 2 is not inside of this box, we know that 2 does not work, so we can just stop there, and we know that the d value stays the same. So now we want to move on to point 4, and once again we create a rectangle. Like this. And once again we want to check every point in the active set, which is only 2. And also 3. Because we have already performed our algorithm on 3. So once again we see that 2 does not fit inside of this range of x values. So we once again can remove 2. And now we are only left with 3. And we see that 3 is inside of this box. So we want to check its distance to 4. And if it is less than the current d, we can set this distance as d. And it is. So this will be the new d value. So once again we can put 4 into the set, and we move on. So now eventually we will get to this point 7, and we will have, let's say, 3, 4, 6, 5, and 6, for example. and we look at this box again, and we see it's something like this, and we see that these don't fit inside of this range, so we can remove these again. And now we only have these 2 points left, and we see that these both fit inside of this box, so we can check the distance between each of them. So we see these, and because this is less than D, this is the new D. And then we go to the next point that fits inside of the box, and we check this distance. But because this distance is not less than D, this will not be used. So now because we're on the final point, that's our answer. So the answer will be D. And that's how you use Sweepline on the closest pair problem.